Okay, we have some interesting news. Due to the generosity of an anonymous crazy person, we've managed to secure a little extra time. But we're going to stay on time, but you will definitely be rewarded with a reception where we hope to have some productive conversation. So we have a little extra time for our evening, but we're going to stay on time with our presentations. So before I introduce Dr. Hayes, I just want to share something important with you. We've had a lot of help and support from many of our leading national cancer agencies. You saw a tremendous presence from the American Cancer Society. Dr. June Dudick from the National Institute of Environmental Health Sciences is here. Dr. Birnbaum, who's the director, asked her to come. We had conversations with Debbie Wynn, who some of you will know is the Deputy Director of the National Cancer Institute of the United States. And she told me a shocking fact. She said, well, Tom, you know, you're not going to believe it, but there are only 2 funded studies by the NCI looking at young adult colorectal cancer. And both of those funded investigators are with us right now. So Dr. Richard Hayes from NYU is going to talk to you about his work, and then our second NCI-funded investigator is going to come up and talk about their work. So Richard, thank you so much for being with us.
Well, thank you very much, Tom, for the introduction. And I didn't know that fact, so we'll try to, very special indeed, right? So I'm going to be speaking about the work we're doing in this NCI-funded study on common genetic risk variants and susceptibility to early onset colorectal cancer. So just to set the stage for those that are not familiar with the notion of these risk variants, you've heard much discussion about high penetrance, moderate penetrance, and low penetrance genes related to colorectal cancer risk. Well, there's a whole other series that Dr. Stoffel mentioned briefly at the end of her talk called simple nucleotide polymorphisms that are also associated with colorectal cancer risks, some 100, actually more than 100 now. But the risks for each individual variant is very small, in the order of maybe a 5% or 8% elevated risk for each of these individual variants. So our interest was in whether one could take the whole spectrum of these 100 or so single nucleotide polymorphisms and devise a simple score, just summing each individual's profile for these. Some people would have a risk variant at, say, at 5 or so or 10 of these sites, and other people would have a risk variant at 20 of these sites. And how does that translate into overall risk for these people, and how does that help us to make decisions about screening of individuals and clinical care? So with that introduction, what do I do here now? Okay, so I've had the privilege to work in the GECKO consortium with a group from the Fred Hutchinson Cancer Center, Ricky Peters, and we're collaborating with the Kaiser Permanente Northern California, Doug Corley, in these investigations. In the GECKO consortium, which consists of some 60 or so different studies, a number of people here in the room contribute to these efforts. So our overall goal is to build a more comprehensive risk prediction model for colorectal cancer using information about, I have to get a little closer to read my slides, using information about environmental factors and genetic factors. And what I'll be talking about today is the work that we've accomplished so far on evaluating the utility of the common polymorphisms, these single nucleotide polymorphisms, for evaluating colorectal cancer risk. So the idea behind what's called a polygenic risk score, this summation of the the carriage of these various risk alleles is that we may, based on a person's score from the lowest, the 0 percentile, to the highest, the 100 percentile, we may be able to make recommendations as to whether someone should start screening at an earlier age or possibly at a later age for that matter. And this is that's motivated on principles of improving early detection initially, but also we became interested, as everyone in this room now is, in this question about early onset colorectal cancer with increasing rates, as you've heard about earlier, and in particular with respect to this very interesting birth cohort phenomenon. So these are two motivations as to why one would be interested in determining whether one can use this information for risk prediction. So our study is an investigation of 95 SNPs of these single nucleotide polymorphisms combined into a polygenic risk score. I won't go into detail how that's done, but it's really, you could think of it as just adding up the number of at-risk alleles across these 95 different sites that everybody carries. We carried out the study in Europeans, and sort of the basic model that we were addressing is, does this polygenic risk score provide a difference in risk for people less than 50 versus those over 50? We will go on, we're continuing to do this work, and we'll be asking basically the same question about other environmental risk factors like BMI and so forth as well. But for today, I'm talking about the genetic scores. So this, the strength of this investigation is that the GECKO and Colon Cancer Family Registry Consortium and the CORRECT Consortium have all joined together to address these kinds of questions. So there are some 50,000 colorectal cancer cases in this, represented in this very large consortium, a similar number of controls. And among the 50,000 cases, there are over 5,000 colorectal cancer cases among individuals who are less than 50. So that's sort of the framework within which we're going to be looking at the relationship of these common polymorphisms to colorectal cancer risk. The study is limited to European ancestry only for practical reasons, certainly not for reasons of interest. And we have information on an individual's first-degree family history. And I should point out that this is not a mega cohort. It's really an accumulation of a large variety of different studies, including case control studies, family-based studies, and some cohort studies as well. So this is the main result that came from this effort, comparing the risk for colorectal cancer among individuals. Let's see here. So we divided the study population, the entire cohort, into those who were negative for a first-degree family history of colorectal cancer and those who were positive for a first-degree family history. And as you understand, of course, the larger numbers are in the negative first-degree family history that, as we've seen before, among those less than 50 years of age, some 60 or 70% of cases will have a negative family history. So the relative risks over the quartiles over the range of this polygenic risk score, the risks go up as one has a higher score, up to, what is this, about a fourfold risk amongst the highest quartile. Which is pretty much known before, that this polygenic risk score predicts for colorectal cancer. But what we were interested in is whether there was a differential for young age, and there is. At each one of these quartiles, the relative risk for young people versus older people is is some 20 to 50% greater for the young onset cases. And that's in the negative first-degree family history group. In the positive first-degree family history group, the numbers are smaller, particularly for those less than 50 years of age, and these confidence limits are wide. So you can see for those greater than 50, the polygenic risk score is predictive of risk, even though we know that much of first-degree family history positive cases, there are rather significant genetic factors in play, but also this polygenic risk score appears to play a pretty significant role. And that may be the case for those less than 50, although, as I said, the numbers are smaller. So the other aspect of this that we were interested in is whether these relationships were any different by tumor site. And I think statistically there's a slight shift that the relative risks are greater for rectal cancer than for, based on this polygenic score. But you can see visually that there's, that the patterns are fairly similar across the three disease sites. We did a replication study, which is important in this kind of 1 minute. Okay, so we did a replication study in the Kaiser cohort and basically found similar rank ordering of the genetic risk score as shown for the large study. So that replicated our findings. There are a number of considerations, a number of limitations of the study. I think we would certainly want to expand this into non-European population. An important point is that the 95 SNPs that we were looking at were generated across large populations that were not focused specifically on those less than 50 years of age. So that's something we would like to add to this effort. And this is the work from Perlman, just pointing out what the space is with respect to family history. Negative individuals, roughly 90% of these people do not have the high-risk traits that were characterized in this study in 2017. But also, I think interestingly, among the family history positive, there's also a lot of kind of blank space as to what the genetic determinants are. So with that, I'll conclude. So thank you.